So let's start in learning rate scheduling. Learning rate is one of the most important hyperparameters that you want to tune when you are training your deep learning model. Why? Because learning rate is one of the factors that affects the steps length you're taking down through the loss function. So if you choose this learning rate very small, like the graph in the right, the training process will take very long and you may get stuck in one of the local optimum. And if you choose this learning rate very big, so the steps will be very big, basically like you will start to overshoot in the loss function values and you will get very strange behavior and unstable training process. You may get something like NaN values in the loss function, and you may get very high accuracy in the training set and very low accuracy in the testing or the validation set. All of these are signs for the overshooting. So how to solve this? First approach is to tune this learning rate and choose it from an acceptable range as a fixed learning rate. The second approach, which is the learning rate scheduling, is better than the fixed learning rate. Why? Because if you choose a relatively large learning rate at the beginning of the training process, you will make bigger changes at the beginning, and then you will make small changes at the end of this training process, which is what we call fine-tuning. In class, this can be done in two different ways. The first way is the callback, which is called reduce learning rate on plateau. The second is the learning rate schedule. So let's experiment both. So this is our model. First, let's import this callback, reduce learning rate on plateau. This is the first way. And the second way is learning rate scheduler. Let's define our callback, reduce learning rate on plateau. The first parameter is the monitor value. What is monitor value? The monitor is the value that it will be monitored by this callback. So when there is no improvement in this value, it will basically reduce the learning rate value by a factor that also we will specify here. So let's make this monitor is the validation accuracy. Second is the factor value. As I said, basically when the performance plateau or in the training, so there is no improvement in this validation accuracy for a specific number of epochs, which here we call patients, similar to the patients in the earlier stopping callback. Basically, we will reduce this learning rate by this factor. How? So the new learning rate will equal this factor multiplied by the old learning rate. So it's better to choose value between 0 and 1. I prefer 0.3. The default value is 0.1. Here's the patients, as I said, is the number of epochs that if there is no improvement in this validation accuracy, we will reduce the learning rate by this factor. And notice that it should always be less than the patients in the early stopping callback. So let's choose 6. This is the first way. Then you add this learning rate schedule, the first way here as a callback. The second way is learning rate scheduler using this callback. So let's see how it can be defined. Let's call our schedule 2. It only takes one parameter, the schedule function. So let's see how we can define this schedule function. It takes two parameters. First is the epoch index and the current learning rate. And it should return the learning rate that you want to specify for the next epoch. Or sorry, for this epoch index. So for example, if epoch index equal 10, let's make the learning rate smaller by this factor. If the epoch index equal 20, for example, let's return learning rate multiplied by 0.5. Else, let's return the same learning rate. And you send this function as a parameter to the constructor of this callback. And you can add it here also. You should add it here to be effective in the training. But personally, I prefer this, but you are free to choose any. That's it with the learning rate scheduling.